Hello, welcome back. Today, I would like to talk about the concept of elasticity in economics. As I will show that there are various areas where the elasticity concept is utilized in our economics course. We can start our discussion by talking about a broader definition of what elasticity is. Now, as a working definition, elasticity measures the change in one economic variable as a result of change in another variable. What does that mean? It means that elasticity gives you sort of like a unit-free responsiveness of one variable when another related variable changes. So it somehow gives you an idea about the responsiveness of the economic variables. Elasticity is frequently used in understanding how market outcomes such as quantity bought or sold changes when any market conditions such as own price, price of related goods, or income changes. Now, in this discussion, we are going to talk today about the various kinds of elasticity concepts that are used in economics. Our discussion today will be mainly confined to the model of market demand and supply. Therefore, we are going to look at the concept of elasticity on the demand side and on the supply side. We will mainly be talking about the concept of elasticity on the demand side and on the supply side of the market model. So let us continue our discussion. The first concept that we are going to encounter is the elasticity of demand, elasticity concept on the demand side. Okay. Before we start that, it is, I think, important to get a general sense of how a demand function looks like. So in the general definition, you can argue that the quantity demanded, which we usually write as QD, is a function of PA, which is the price of the good in question, PB, which is a related price of a related goods in that function. I stands for the income, taste, market size. All of them could affect the quantity demanded of a certain good. So demand side elasticity measures how quantity demand changes whenever any of these factors on the right hand side changes. We will mainly be talking about the first of these factors on the right hand side, mainly PA, PB, and I. The first elasticity concept that we are going to look at on the demand side is called the price elasticity of demand, which is very popular. The price elasticity of demand measures by how much quantity demanded changes whenever its own price change. So let's look at equation number 2, which gives you a very generic idea about percentage change in demand. So elasticity of demand, which is usually represented by epsilon D, is a ratio between the percentage change in quantity demanded in the numerator and the percentage change in price in the numerator. This is a very generic way. So percentage delta, when you look at the last part of this equation here, percentage change is percentage change, and then there is a delta sign, and then QD, which really is talking about how quantity demanded is changing, and in the denominator you have percentage change in price, which means how the price level of the economy is changing. So it's a ratio between those two. So we have basically two ways of calculating price elasticity of demand. One is the traditional method, where the key thing between these two ones are how these percentage changes are calculated. So when we look at the when we look at the traditional method of calculating the elasticity, it is usually written as follows. So let's look at that. In the traditional method, percentage change in price is you identify the new price, you subtract that from that you subtract the old price divided by the old price times 100, and your percentage change in quantity demanded is you identify the new quantity demanded, you identify the old quantity demanded, you subtract the old quantity demanded from the new one, so divide that by old quantity demanded and times 100. So let us take a moment to try to understand the concept of elasticity from a graphical perspective. What does price elasticity of demand actually is telling us? Imagine that you have a demand curve, okay, and the price is measured by the vertical axis and the quantity demand is measured by the horizontal axis. And imagine that the original price was P1 and the new price was P2. So when the price was P1, quantity demanded was Q1. When the price is P2, quantity demanded is Q2. Let's say the original point was A and the new point is B, and our price elasticity of demand really captures the change in demand when price changes from P1 to P2. So notice that when price is changing from P1 to P2, your quantity demanded is changing from Q1 to Q2. So therefore, the change in quantity demanded is approximated by a movement from A to B, right? So the way to approximate the movement in quantity demanded from A to B is by using these two ratios, changes in price, which is this part, and the changes in quantity, which is the horizontal part. Get a ratio, and that is that according to a deeper mathematical interpretation approximates the move in demand from A to B. Now one could argue that this movement is also captured by the concept of slope, right? For a demand curve, whenever prices move and quantity demanded moves accordingly, the changes in demand could be represented by the changes in quantity demanded, or changes in the demand behavior can be summarized by the slope as well. But the problem with slope is that slope really does not capture the percentage change or the rate of change at which price changes affects the quantity demanded. So when we look at the definition of price elasticity of demand or any elasticity of demand, it gives us a unit free percentage change or percentage responsiveness of our targeted variable, which can be quantity demanded or quantity supplied whenever any of the underlying variables change. So in trying to calculate elasticity, we are basically trying to approximate the change of going from A to B. Now, the traditional method assumes that you have to come up with the new price and the old price, you have to come up with the new quantity and the old quantity. So that really creates a little bit of ambiguity, because you can go from P1 to P2, or you can go from P2 to P1. So it doesn't really matter. Now when we go back to the definition one more time of how to calculate price elasticity using the traditional method, you would realize that the new price and the old price could be ambiguous. It could be the same thing. As a result, the way to calculate percentage change in price and the way to calculate percentage change in quantity demanded could be arbitrary. And that's why sometimes we do not use the traditional method to calculate price elasticity of demand. What we do, however, is use the second method, which I'm going to look at in a minute, which is called the midterm formula of calculating price elasticity of demand, which is more concrete, more less controversial. But if sometimes you are given sufficient information, we can really use this traditional method to calculate price elasticity of demand. So let's look at an example. The example that we are looking at is talking about the price of tacos rising by 4% and the quantity demanded decreases by 10%. Okay, so we exactly know the percentage change in P, and we know the percentage change in quantity demanded. So all we have to do is find out those. So notice that percent change in price is 4, percentage change in quantity demanded is -10. When we substitute those values in the denominator and the numerator of our equation, we find the price elasticity of demand is -0.25, or the absolute value of the price elasticity of demand, which is indicated by putting two brackets on elasticity of demand, is 2.5. Okay, now this number is important. This number tells us that -2.5 tells us that whenever there is a 1% change in price, our quantity demanded changes by 2.5%. But the negative sign is of utmost importance, because negative signs tells us that price and quantity demanded move in opposite direction, which means that this negative 2.5 is telling us that whenever price increases by 1%, quantity demanded decreases by 2.5%. Okay, more on that later. The midpoint formula is pretty similar to the traditional method. The only thing is that when we look at the percentage change in price and quantity demanded, and we look at the denominator of this calculation, we notice that the denominator is a weighted average between the new and the old, both for percentage change in price and for percentage change in quantity demanded. In both cases, we find the denominator as a weighted average of the new price and the old price by adding them and dividing them by 2. You also do the same thing for the quantity. You add the new quantity and the old quantity and divide it by 2, and that studies have shown gives you a better approximation of the elasticity of demand. In order to convince you that the midpoint formula is more stable measurement of elasticity of demand, I urge you to go back to the graphical example that I just provided, and imagine P1 to be the new price first and then P2 to be the new price. Calculate price elasticity of demand by using P1 Q1 once as the new price and P2 Q2 as the new price and quantity another time, and convince yourself that the midpoint formula always gives a measurement of elasticity which will be between those two. Okay, so now an example of how to calculate elasticity with the midpoint formula. So let's look at the question. So the question we are looking at is an example where it is said that the price of coffee falls from $3 to 2.5. The quantity demanded increases from 1,000 to 1,150 per month. So we are going to use the midpoint formula to find the prices. Notice in this example it is a little bit clearer because we know which one is the old price, which one is the new price. The old price is $3 and the new price is $2.50. The old quantity is 1,000 and the new quantity is 1,150. So percentage, according to the midpoint formula, the percentage change in price is when you plug in the numbers, and you can see, you can follow that 2.5 minus 3 is in the numerator. In the denominator you are taking a weighted average. So when you do the calculation at the end, you are going to find that the percentage change in price is minus 18.18. Similarly, when you plug in the numbers, you're going to find that the percentage change in quantity demanded is 13.95. So once you calculate the percentage change in price and percentage change in quantity demanded by using the midpoint formula, you take those numbers, you plug in into the equation, and then you find that the price elasticity of demand is minus 0.7673, which is approximately equal to 0.77. So the absolute value of elasticity of demand is 0.77. So this first number tells us that according to the midpoint formula, whenever there is a 1% increase in price, there is a 0.76% decline in quantity demanded, and vice versa. So we have just gone over the two traditional methods of calculating price elasticity of demand. Let us now move forward and try to understand other aspects of this price elasticity of demand. The first one that we are going to talk about is that the sign and the magnitude of the price elasticity of demand is very important. The first thing that we want to talk about, remind ourselves, is that we have a law of demand, which says that anytime price increases, quantity demanded would go down, or vice versa. Which means that anytime price goes up, quantity demanded goes down. As a result, the sign of the change between percentage change in price and percentage change in quantity demanded are always going to be opposite. Which means that in the formula that we are using to calculate price elasticity of demand, the denominator and the numerator will always have opposite sign. So it is important to know that the price elasticity of demand is always a negative number. So that's a very important thing. Also is important is the magnitude of the price elasticity of demand. In order to understand the magnitude of the price elasticity of demand, we only consider the absolute value of the price elasticity of demand. If the absolute value of the price elasticity of demand is greater than 1, we say that the demand is elastic. If it is less than 1, we call it inelastic. If the price elasticity of demand is equal to 1, we say that the demand is unit elastic. Okay, now, does the price elasticity of demand change over time and change with the kind of market conditions? The answer is yes. And let us focus on several ones that are kind of important. The one that we are going to look at right now are these four, right? For example, the first one is talking about the availability of substitute. If the good in question has good substitutes, then its demand would be elastic. What do you mean by that? In order to understand that, let us go back to our board one more time and try to understand the difference between an elastic and an inelastic demand curve. An elastic demand curve would look like this compared to that. So if 2 and 1 are the two demand curve, 2 is more elastic than 1. Why? Because as you can see that for the same change in price, let's say from P1 to P2, the percentage change in quantity demanded under 1, let's call it Q1 to Q2, is going to be more than percentage change in quantity demanded under 1, let's call it Q3 and Q4. So we see immediately that demand curve 2 is more elastic. So a question that we want to ask ourselves, that why and how can a demand curve become more elastic? So let's imagine that originally we had a market where demand was very inelastic, meaning that there was only one producer, so the good that the consumers were buying had a very inelastic demand. Now over time, if other competitors join in, they start making substitute products, our demand curve will slowly pivot and slowly become more and more elastic. So that is the intuition behind the factors that affect the elasticity of demand. And let's go back. So if we have good substitutes, then demand would be elastic. If the good is a luxury good, which means that you really do not need that good to survive, your demand for that good would be very elastic, meaning that anytime you get a huge discount on a luxury product, you would be more willing to buy that, as opposed to if the good is a necessary good. Then if you have a smaller budgetary allocation for that good, meaning that the good is cheap, you really do not pay attention to the price changes. So the classical example that we provide for number 3 is salt. Salt is a necessary good, and whenever the price of salt changes, I would argue that nobody really pays attention, so the demand is very inelastic. Finally, it has been observed that over time, since we find more and more substitute, close substitute for the good in question, we will have a situation where over time demand would become more elastic. Okay. Now let's move on to the next topic, which is a discussion about how price elasticity of demand is connected with a very important microeconomic concept called revenue. So let us start with a very general definition. Revenue or total revenue is the amount of return on some kind of investment. So if a firm sells something, whatever they get in return is called total revenue. So generically, the total revenue can be written as P times Q, where P is the price that the consumer firm is charging and Q is the amount the firm is able to sell. As it turns out that the price elasticity of demand is intrinsically connected with the total revenue. Now with the help of a little bit of calculus, we can write this equation as follows. We can say that the percentage that the changes in total revenue is equal to the sum of changes in price and changes in quantity demanded or quantity. In this situation, we can therefore now see two kinds of relationship. For example, if the demand is elastic, meaning that price elasticity of demand is greater than 1, we know from the equation that delta Q is greater than delta P. So if a firm cuts its price, meaning that price goes down, total revenue is equal to percentage change in price, which is negative, plus percentage change in quantity, which is positive because of the law of demand. And since delta Q is greater than delta P, meaning that changes in quantity is larger than changes in price, we have the final result that the total revenue is going to go up. This is a very critical issue, which argues that if the demand is elastic, a firm can raise its revenue by cutting price. On the other hand, imagine for the time being that the demand is inelastic. If demand is inelastic, it means that our delta P is smaller than delta Q. And if that is the case and a firm cuts its price, your total revenue is equal to delta P, which is negative, plus delta Q, which is positive. But since delta P is now greater than delta Q, we will have that our delta total revenue is going to be negative, which means that when demand is inelastic, a cut in price really reduces revenue. So we can therefore argue that whenever demand is inelastic, a firm can increase its revenue by raising price. A very important point. Okay, so that concludes our discussion about price elasticity of demand. The next one that we are going to look at is called an income elasticity of demand. The income elasticity of demand is a fairly important concept. Let's read the definition first. Income elasticity of demand measures by how much quantity demanded for a product changes whenever income changes. So mathematically, income elasticity of demand is usually indicated by epsilon EI, which is measured as follows. You find the percentage change in quantity demanded in the numerator, you find the percentage change in income in the denominator, you take the ratio and you get the income elasticity of demand. Now the method of calculating income elasticity of demand is very similar to the price elasticity of demand concept that we looked at before, which means that we can either use the traditional method or the midpoint formula method. They are going to be very similar. The only thing that is going to be different in the income elasticity of demand is that for income elasticity of demand, you have to calculate the percentage change in income, which is going to be very similar to the other concepts where you take the new income, subtract old income, and take the weighted average of the two incomes in the denominator. Your percentage change in quantity demanded is going to be calculated either by the traditional method or the midpoint formula in the same way as you did before. Once you calculate these two, you take the ratio and you calculate your your income elasticity of demand. Now, as opposed to the price elasticity of demand, which was always negative, our income elasticity of demand can be both positive and negative. It will depend on what kind of good we are talking about. So what do we mean by that? In our discussion of demand, we talk about two kinds of goods that we regularly buy. One of them is called a normal good. A normal good is a good for which whenever income increases, the quantity demanded increases. Okay? So when income increases, quantity demanded increases, which means that for a normal good, the numerator and the denominator in the income elasticity of demand concept are always going to have the same sign. This is important because for a normal good, therefore, our income elasticity of demand is always going to be positive. On the other hand, we have an inferior good. This is a good for which as income increases, quantity demanded decreases. We have provided a lot of examples about inferior good. The classical example of an inferior good is ramen noodles, where as your income is low, you are an undergraduate student, you buy a lot of ramen noodles. When you graduate, when you have more income, you buy less ramen noodles, although the price of ramen noodles really did not change. Now, for an inferior good, the percentage change in quantity and the percentage change in income always move in opposite direction, and hence for a inferior good, the income elasticity of demand is always negative. That's a very important point. Okay, let's now look at the next concept of elasticity, which is called a cross price elasticity of demand. Now, there is a typological mistake. I apologize for that. Cross price elasticity of demand is a measurement that measures by how much your quantity demanded changes whenever the price of a related good changes. Okay, what do I mean by that? Imagine that there are two goods in the market. One is good A and another one is good B, and we are trying to find the cross price elasticity of demand for good A, which means that we are trying to figure out what happens to the demand for good A when the price of good B changes. The way to calculate that is we find out the percentage change in quantity demanded for good A, we find out the percentage change in the price of good B, take the ratio and calculate the cross price elasticity of demand. You can imagine that the way to calculate cross price elasticity of demand is very much like how we calculated price elasticity of demand. where the percentage change in quantity demanded is for good A is going to be identical as how we calculated percentage change in quantity demanded. Now percentage change in price B will be the same as percentage change in the price of good in question, but we are gonna look at good B or related goods. So it seems like in this discussion it is very important what kind of relationship holds between these two goods, good A and good B. As we are going to see in a minute, that depending on what kind of relationship exists between these two goods, our goods in question could be the cross price elasticity of demand could be a positive number and a negative number. Let us carry on with this discussion. We are going to now look at another two variations of the goods that are regularly purchased together. One good is what we call a complementary good. A complementary good is a good for which whenever the price of good B increases, the quantity demanded for good A decreases at the same time, and vice versa. An example of a complementary good would be sugar and coffee. So whenever the price of sugar increases, our consumer buys less sugar, and since sugar is a complementary good to coffee, our consumer also buys less coffee. So an increase in the price of sugar therefore decreases the quantity demanded for coffee. So in case of a complementary good, the sign of the denominator and the numerator in equation 3 will always have opposite sign, and as a result, for a complementary good, cross price elasticity of demand is always negative. So that's our complementary good. The other kind of good that we are going to look at is called a substitute goods. Two goods are substitute whenever as the price of good B increases, as the price of good B increases, quantity demanded for good A increases, and vice versa. So let's put this idea into a context. And a classic example of goods which are substitute goods are Coke and Pepsi. So if the price of Pepsi increases, many people would say, hey, I like Coke, I am indifferent between Coke and Pepsi, so I will switch towards buying more Coke because Pepsi is now more expensive. So whenever the price of Pepsi increases, quantity demanded for Coke actually could go up. So when we are thinking about Pepsi being B and Coke being A, an increase in the price of Pepsi will lead to an increase in the demand for Coke. As a result, the sign of the denominator and the numerator will always be positive, will always be in the same direction for the equation number 3, which means that the denominator and the numerator will always have the same sign. If they are negative, both of them are negative. If they are positive, both of them are positive. Therefore, the cross price elasticity of demand for two substitute goods are always positive. Okay, so that's interesting. Let us now spend some time looking at some examples. Okay, so let's look at the first example. Example 1 says that if the price of the movie rises by 3%, the quantity demanded for video rentals increases by 6%. Then find the cross price elasticity of demand and comment on what kind of goods movie and video rentals are. So following equation number 3, we can simply plug in the numbers where percentage change in quantity demanded for video rentals is 6, percentage change in prices for movies are 3, both of them are positive numbers. The cross price elasticity of demand is 2. Notice that as we have argued, if the cross price elasticity of demand is positive number, that means movie and rentals are indeed substitutes, and then the demand is actually quite elastic because it is price elasticity of demand is greater than 1. Okay, so that's good. Let's now look at an example where we are going to calculate income elasticity of demand. So let's look at example number 2. Example number 2 is talking about Joe. He receives a 20% increase in his income from his part-time job, and as a consequence decrease his consumption of ramen noodles by 10%. What kind of good are ramen noodles for Joe? So we see an increase in income by 20% and a decrease in quantity demanded by 10%. So in equation 2, if we plug in the numbers, our numerator is -10, our denominator is +20. So we are going to have an income elasticity of demand which is -0.50. So the minus sign indicates that our ramen noodle is an inferior good, and the magnitude of the elasticity indicates that our demand for ramen noodle is inelastic. Okay, income elasticity of demand is inelastic. So that really concludes our discussion of the three predominantly discussed concept of elasticity in the context of demand. Now we are going to talk a little bit about the concept of elasticity on the supply side. A typical supply curve looks like the one that you're looking at. The supply curve of quantity supplied of good A depends on the price of good A, price of other related goods. Let's ignore income for the time being. Income probably is not that important. Income is probably not that important. Let's okay, income, there is a typological error there, so let's just ignore that, and then let's just delete that one. Then price of inputs, they are pretty important, and then technology, market size, they all can affect the price elasticity of supply. So supply side elasticity measures how quantity supplied really changes whenever the market conditions changes. We can look at how quantity supply changes with respect to PA, how it changes with respect to PB, price of inputs, technology, everything. Just like the price elasticity of demand, the price elasticity of supply, which is indicated by OS, can be written as percentage change in quantity supplied divided by percentage change in price. It can also be calculated by using the traditional method and also by using the midpoint formula. So now the sign and the magnitude of the price elasticity of supply is also important. We know that there is something called law of supply, which says that whenever the price increases, quantity supplied increases. That means that for a supply curve, the direction of the change in price and the direction of the change in quantity supplied is always in the same direction, which means that in equation number 4, the denominator and the numerator will have the same sign. As a result, the price elasticity of supply is always a positive number. Just like the price elasticity of demand, if the magnitude of the elasticity is greater than 1, we call it elastic. If it is less than 1, we call it inelastic. If it is equal to 1, we call it unit elastic. Okay, now let us spend a little bit of time trying to understand the factors that affect the magnitude of the price elasticity of supply. We can actually talk about several items, which is fairly important. For example, we have a good where the good is being produced at a constant opportunity cost, meaning that the cost of production is constant. Then we will have an elastic supply. Goods that can be produced only with a fixed quantity, meaning that the resources probably are limited, so the supply is going to be inelastic because it's difficult to really increase the production. And then the next one is we can think about the time. The issue of time is kind of important. As time passes after a price change, the producers find it easier to change their production plans, because with a longer time window, their production is more flexible. As a result, supply becomes more elastic over time. Also, if the good is storable, then the supply of the storable good is price elastic. Okay. Let us now look at an example. The example is straightforward. So we have a situation where the supply was 200 units when the price was 50, and it is 100 unit when price is 40. We really don't know which one is the new price and the old price. Let's for the time being assume that 20 units is the old quantity, 100 unit is the new quantity. Then if that is the case, we can calculate percentage change in price by using the midpoint formula, just like you are seeing. So once you plug in the numbers, you will see that the price elasticity of demand, the price elasticity of supply actually is minus 22.20. If you plug the numbers, you will see that the percentage change in quantity supplied is also a negative number, minus 66.67. So therefore, once you plug the numbers, your price elasticity of supply is going to be 3.0, which means that as you can see that the price elasticity of supply is a positive number, but on top of that, the price elasticity of supply is greater than 1, which means that the price elasticity of demand is elastic in this case. Okay, so that concludes our discussion about the concept of elasticity in economics. I hope that you have enjoyed this discussion, and if you have any question, please come and talk with me or send me an email. Have a nice day.